So I'm here today, as Marie said, to talk a little bit about Baseload Capital, what we're doing, our geothermal heat and power projects, and then the bigger picture. Why are so many people interested in geothermal right now? So let's start with the bigger picture. That's always a little bit exciting. Why is it that people are turning their eyes towards geothermal right now? I think there are several factors leading up to this. As always, it's not just one thing, but it's a matter of, stars aligning. So for the past decade, the deployment of solar and wind has grown rapidly. So much focus in the renewable energy industry has been on solar and wind. Yet now we're seeing that in 2019, renewables was only 23% of the global electricity generation, despite that huge growth. What does that mean? That means that more than 75% of the electricity generation is still coming from fossil sources, non-renewables. And I think getting all of this solar and wind, the intermittent energy sources, getting it into the grid has shown that what a big need we have for a baseload power. And if we want to replace the rest of those 75, 77%, we need a baseload that's renewable and something that works 24/7. We need a stable, renewable energy source. And in countries like Sweden, hydropower could fill that role. But not every country has an abundance of water and mountains. So I think that's a reason why many are looking at geothermal. Another factor that plays into this, I think, is the discussion that's going on in society. And over the past years, we've seen an increased pressure on the energy giants, the oil and gas companies mainly, to be part of the energy transition. And I don't know about you, but if I was a company that had competence in exploration, drilling, well management, geological surveys, I think geothermal would be a pretty good place to look if you want to invest in a renewable energy source. There's so many of the competencies you have in the oil and gas industry that could be applied in the geothermal sector. And another part is, when an oil well becomes depleted, what's left? It's hot water. You have, at the end of the lifespan of an oil well, you have basically 98% water. And then you have all of the abandoned wells, the ones that didn't produce oil. So there really is a huge potential for the oil and gas industry to increase their focus on geothermal. It could be a very, very good next step for them. And then, of course, third, but not last or least, I'd say, we have the financing. So there has been more and more capital flowing towards the renewable sector in the past years. We have the European New Green Deal, a lot of investments being made into sustainable companies, renewable energy. And solar and wind has been around. I mean, they have matured quite a lot over the past decade. So a lot of investors, these are quite mature investments. So they're looking for the next big thing. And one of those things could be geothermal. And now someone might want to point out, hey, geothermal, it's not a new thing. I know. The first geothermal power plant, it's been around for over 100 years. So it's really not a new thing. But what has been happening over the past couple of years is a technology shift. So traditionally, when you're talking about geothermal power production and geothermal energy, this is something it's been high temperatures. You're looking at 150 to 300 degrees Celsius. This is, these temperatures you find along the tectonic plates, the ring of fire, really. And so these countries that are along the ring of fire, they've been using geothermal power for decades, almost a century in Italy, at least. But what's happened now is that new technologies allow us to utilize the lower temperatures And it can still be financially feasible to put up a power plant, even if you only have 110, 120 degrees Celsius. So when you're looking at these lower temperatures, the potential is suddenly so much bigger. You can do geothermal in large parts of the world. For example, in Hungary, you have basically a 100-degree swimming pool beneath the surface. And that, if you can actually use that for power production and heating, you can do geothermal heat and power all over. And that's really the shift that's happening. And the energy available, I mean, that's enough to power the world's energy need. So it really is, it's a huge potential, but it's not been in focus. Solar, wind, they've been great at highlighting their strengths, but geothermal has been sort of the quiet one in the corner. And I think one big shift that's happening with these new technologies is that when you think about geothermal power, you think about these huge 300 megawatt projects. They take years to develop. You build tailor-made power plants. Typically, you're looking at 7-10 years before you actually have a power plant in place. But with the new technologies that are typically modular, scalable, you can reduce the time from investment to cash flow a lot, and that is attractive for investors. It's a lot easier if you're looking at these small power plants. There's less of an environmental impact, less risk in the project. Obviously, building 10 smaller power plants is less risky than building one big, betting everything on the one power plant. So these are a couple of the things that's happening in the industry. We are seeing that there is a potential for low temperature geothermal power production. And another thing that not a lot of people understand is the difference when it comes to footprint. So I come from Sweden. It's a pretty big country with not a lot of inhabitants. So we have a lot of space, which is why we also have a lot of wind power. We do have a lot of solar panels as well, even though we don't always have that much sun. But for other parts of the world that are more densely populated, size is a really important factor when it comes to power generation. You just simply can't cover all of the land with solar panels, or you have these huge wind parks. But with geothermal, especially since they work 24/7, you get a lot more power in a lot less space, which I think is really going to be a big benefit going forward. Many countries are having these debates whether we should be covering agricultural land in solar panels. Do we want wind power plants next door? Will they ruin the view? Will they disturb the birds? All of these issues. And I think geothermal really has a benefit here, that you can have it quite close to the populations. You don't really have these, it's not noisy, it doesn't disturb. You can put it in a small house and hide it away. But knowing all of this, why isn't geothermal everywhere? Because I mean, in Sweden, it actually is for heating. It's super popular. But still, it's such a great renewable energy source. It works 24/7. Now you can do it in larger parts of the world. But why isn't it everywhere? So I think a common problem for emerging technologies, any type of new business, is financing. Even though these smaller distributed power plants require less of an upfront investment than a huge power plant would do, a traditional geothermal power plant, it's still a lot of money that you need. So one of the best ways to speed up the deployment is to make sure that you can access capital to deploy these. And the big banks are typically very, very risk averse. Today, you could go to your bank and say, I want to put up solar panels, and they'll help you finance it. A decade ago or 15 years ago, it wasn't as easy. They were more risk averse. It was a little bit untested. And that's really where the low temperature geothermal is today. So we saw this opportunity that, if we want to deploy this technology, if we want to accelerate the shift towards renewables and geothermal in particular, we need to make sure that there is financing available. And that's why we founded Baseload Capital in 2018. So what we do is that we're an investment company, and we offer early stage financing to developers within the geothermal sector. So we can provide equity or debt and the support they need to develop their projects. But what we quickly realized was that if we really want to make an impact and we want to do it now, it takes more than just capital. There are a lot of great geothermal developers out there, but many of them are focused on high temperatures. So we saw an opportunity to build up these teams specialized on low temperature geothermal heat and power, which we call our baseload power companies. So today we have companies in Iceland, US, Japan, and Taiwan. And of course, we're not alone in this. As our marketing manager always says, if you want to go fast, go alone. If you want to go far, go together. So with us, we have a great group of founders and owners. We have the Swedish family offices focused on sustainable investments, Gullspång, Blue, and LMK. We have Breakthrough Energy Ventures, which is a fund backed by some of the world's top business leaders, such as Bill Gates. We have Climon, a technology supplier within the geothermal area. And most recently, we added Chevron Technology Ventures. So what we do at Baseload Capital is that we combine the strengths of the Baseload Capital and the Baseload Power teams. And we do this to accelerate the deployment of low temperature heat and power. So at the capital team, we can provide financing. We have a proprietary prospecting tool to make sure that we identify the right areas in the world where we see the greatest potential for low temperature resources. And of course, we have good knowledge and relationships with the various suppliers out there. And then we have the power teams who are working on finding the right land lease agreements, finding the right areas, doing the geological surveys, the business case, and then eventually developing the full project and building the power plant. And I think the best way to actually understand what we do, how it works, and get some inspiration is to see the real deal. So I want to bring you to one of my favorite places in the world, this beautiful little green island, Iceland. So I'm not sure if you've been to Iceland, but they have a really long tradition of geothermal power production. And they have an abundance of hot water. However, these low temperature resources have mainly been used for heating and not for power production. And despite all that they have all these large geothermal power plants and they have a lot of hydro power plants, they supply electricity to the national grid. They still have issues out in the nodes with electricity supply, and there's a big interest in the local municipalities to become more self-sufficient and to make sure that they have their own power production. And the Icelanders, they take a lot of pride in being independent. So many of these local communities, they want to be self-sufficient, and they're looking for ways to make sure that they can supply their inhabitants with electricity and heating, and renewable electricity and heating, of course. Fossil just isn't an option there. So we had this team called Varma Orka, a group of Icelandic project developers, and they saw this opportunity, got in contact with Baseload Capital, and we decided that we wanted to help and finance their vision. So together, we headed to this small municipality of Fludir, which you'll see on the map. And this is an area that's really rich in geothermal heat, but it's been used mainly for heating, houses, district heating. But now they wanted to try out power production. So the municipality has been involved in this project that I'm going to tell you about since day one. And they actually own a share in the power plant because we believe this really creates a win-win situation. We want them involved and we want them to feel that this is their power plant, supplying both power and heat to their community. So what we did was we started in February 2018, looking at this project, signing an MOU. We want to put up a small power plant, just 600 kilowatts. It's a start. You got to start somewhere. We did the pre-study, pre-feasibility studies, and started designing the project. The land lease, grid connection, PPAs, all of these things that you need for a power project. And only a couple of months later, in November, so less than 10 months, we produced the first kilowatt. And I mean, before that, we had so many issues. There were, as always, when you do something new, start a project, things happen along the way. But the really great thing here was that Baseload Capital, together with the developer Varma Orka, the technology supplier Climon, and then the municipality, we all shared this common vision of supplying the community with clean power and heat. So it was really easy for us to sort of gather around that and make sure that we just kept solving these problems. We had an issue. It was raining for 2 months in the summer. So the foundation, the concrete, it just wouldn't burn. And we're not going to make that mistake again. But things like that happen. And you need to make sure that you have a good team that will just work through these steps. Since then, we've continued working on this first power plant. And what we did this year was that we expanded the power plant, because that's another huge strength of these small scale power plants, is that we could put up 600 kilowatts, start generating electricity, selling it to the grid, getting a revenue, and then invest in a new well pump, increasing the water flow, and then being able to put up additional of these heat power modules, doubling the capacity of the power plant. So this is a way we like to work, especially since these are the first projects that we really need to work with constant improvements, make sure that we have a local community supporting us, and that we've sort of won their trust before we build anything bigger. And I think something that shows this was that when we had an open house, the power plant, I mean, everyone knew in the community that this was happening. We had probably a third or 2/3 of the community attending our open house, which I think is a really, really great proof of how you can gather around electricity and heating, because it's a great project. So what they're doing right now in Fludir, I was there just 2 weeks ago. Right now they're putting up the piping to connect the power plant to the local district heating network. Because something that they're really good at in Iceland is combining heat and power. You don't waste energy. You're not allowed to do it. So if you're utilizing the hot water for power production, you better be using it for heating as well. And this could be heating housing, or it could be heating a greenhouse. But they're really, really conscious about utilizing the resources as much as possible. So another place that I want to take you to is Japan, another island. So Japan has, since the Fukushima disaster, struggled with their electricity supply. So they've been looking to find a new stable source. And of course, the ideal would be something renewable. Today, almost 90% of the energy that they use comes from fossil. So there really is a need for a big transition in the country. And like a lot of other countries, temperatures vary, and heating and cooling is something they need as well. So what we wanted to do in Japan was to be part of this transition. And we want to do it together with the local communities. So we decided to start out in a very small way with 2 pilot projects and make sure that we build trust in the market. So one of the first projects we did was Shika Power, which is a bottoming cycle of an existing power plant. So you have these traditional high temperature power plants, and the waste heat from those are perfect for an ORC module. So you can actually produce more power from the from the energy source before you pump the water back into the ground. And this project took us about 9 months from start to first power production, and only a year after commissioning, it was the first profitable quarter. And I think that's quite amazing for a power project. It is a small one. It's 150 kilowatts. So, it's tiny. This is a pilot. This is just a way to show that we can work together with the larger geothermal players. So this is a 2 megawatt geothermal flash plant, and we have added a small ORC module that uses the waste heat. And I think this also showcases the circularity, making sure that you utilize all the energy you can. Don't waste anything. Another part in Japan, which they have in common with Iceland and many of these countries that have a lot of geothermal potential, is they have a tradition surrounding hot springs. And the onsen culture in Japan is really, really strong. It's been a tradition for centuries. And the onsen community has been quite hesitant towards geothermal power production because they've been afraid that geothermal power plants would harm their hot springs, deplete them. And a lot of these resources are also found in national parks. So there's been a lot of questions regarding the environmental impact a power plant could have. But the benefit of these small scale power plants is that you have very little impact. And what we wanted to do was build trust with the onsen community and show them that it could actually be beneficial for them. Because the younger generation aren't going out to these onsen spa hotels in the same way as previous generations. So many of them are struggling with their profitability. And they have wells drilled, they have hot water, but in order to swim in it, you have to cool it down. So they are cooling down hot water, 120, 140 degrees Celsius. They're cooling it down so you can swim in it. And what we can offer is that by building a power plant connected to this onsen spa, you can produce electricity, get an extra revenue stream while cooling down the water. And that's exactly what we did together with Midori-san in Kitsune in Gifu. So here the power plant, you can see it on the right side in front of the hotel. And and it's 150 kilowatts. It's just a small pilot, but it's integrated with their traditional onsen spa. Once again, it took only 9 months from the start to power production, which is really, really short for power companies. But it's showing that we can work together with onsen owners, district heating networks, that we can work together and supply a renewable heat and power solution. This is also the first project that we connected to the grid in Japan, which is a very, very difficult process. And we're very, very proud that this was so well received within the onsen community, that they actually saw it as a relief that they could produce their own electricity. They could have another revenue stream to support them and make sure that the tradition of onsen can continue in the future. So this is a short introduction to the type of power plants we're building. And most of them are connected with heating, because the potential within geothermal doesn't only lie in power production. It also lies in heating. And in Sweden, I mean, ground pump heating is the most common today. So there has been an enormous development there. And we see that that will happen in other countries as well. If you want to learn more about geothermal, about community engagement, how we work together to supply heat and power, I want to invite you all to visit our website, YouTube channel. I have a lot of videos explaining, but also attend our next webinar that will be on November 15th. But before that, I want to summarize in a way that Joe already did in the invitation. The earth has power. Let's switch it on.